Hello and welcome to SudoKanard. Here is another puzzle that was created for my birthday by my friend Fabien Douté, who's the one who decided to contact all those great authors from around the world. And on this occasion, he created his first Sudoku, especially for me. And I'm really grateful for that, especially considering that the variant is quite fun. Well, if you're familiar with Little Killer Sudoku, you can see that here we have little killer clues, which means that 11 is the sum of those 3 digits, and 23 is the sum of those 4 digits. So that's something. And then you can see some dominoes here. And the rule with yellow dominoes is that they contain prime numbers. So this is a prime number written from top to bottom. This is a prime number written from left to right. And there are 2-digit prime numbers under 50. That's important. And then those purple dominoes contain pairs of digits, obviously, whose product is over 50. So there's under 50 and over 50 for some reason. And that's it. So let's begin with that. Let's consider what you can put in such a domino. If you try to put a 5, then the maximum product is 45, which is not enough considering that they must multiply to a number bigger than 50. So those digits in purple cages, in purple dominoes, they must be from 6, 7, 8, 9, which means that they form quadruples. And then there's this given 7, which prevents all of those 3 from being 7s, so the 7 must be here. Now 7 times 6 is 42, that's not enough. So that's not a 6. So there's a 6 somewhere here, but if I try to remove the 9, then I get 6 times 8, which is 48, and it's under 50, so that doesn't work. So we must remove 8 from those and put the 8 in here. 7 times 8 is 56, that's correct. And 6 times 9 is 54, which is also correct. They are both over 50. We can remove 8 from this and 7 from that just by Sudoku. So that's some sort of beginning. Now, those yellow dominoes must contain prime numbers under 50. So that's numbers under 50 to begin with. So this 10-digit here must be at most 4, and it can't be 1, 2, and 3, so that's a 4. And this is at most 4, but it's not 4 nor 3, so that's 1 or 2. Here, that's not 1 or 2, so that's 3 or 4. That's not 2 or 3, so that's 1 or 4. And here, that's 1, 3, or 4. Now, considering the unit digits, so a 2-digit prime number must end with either 1, 3, 7, or 9. So this is 1 or 9, considering this 3. So 41 is a prime number, 43, 47 are prime numbers, but 3 and 7 are not available. 49 is not a prime number, so that must be a 1. And that's a 2, that's a 9. 29 is a prime number indeed. This one makes this a 4, and that's a 3. And that's not 4. So 31 and 37 are the only options, but 1 is not available, so that's a 7. I can remove 7 from there and 8 from there, because 7 has to be multiplied by 8 in a purple domino. So prime numbers with a 4 are 41, 43, but 3 is here, and 47. Here I need another 1, 3, 7, or 9, but considering this, that must be 1 or 3. We get a 1, 3 pair, so that's a 7. 47 is a prime number under 50. And here both options work. 13 and 31 are both prime numbers under 50. So that's not 7 and that's not 8. Here we have a 6-9 pair, and that's an 8, that's a 7. So that's a neat start from the domino clues. Those 7s, just put a 7 in here by Sudoku. Those ones, put a 1 somewhere in here. Those 1s and those 3s, put a 1-3 pair in here, so that's a 4-5 pair down there. Next, here we have 6, 8, and 9. Because of this 2 and this 2, on this row, 2 must be here. And because of this 8 and this 8, 8 must be here, which removes this candidate. On this row, I still need an 8, but it's not here because of this 8, so it's here. And that's a 6-9 pair. And here, that's a 4-5 pair. And the second 6 or 9 must be somewhere in here. And here we have the second 6 or 9 and a 5. This digit here, that's 1 or 3, can't be here, so it must be somewhere in here. So the remaining options here are 2, 4, and 5, and that's not a 2. So I'm just doing Sudoku elimination as much as I can. And here we have digits from 1 to 4, 3, 4, 5. That's a lot of options. On this column, I still need 5, 6, and 8. That's not a 5 because of the 5 in here. And that's interesting regarding this 11 sum. If I try to put an 8, then the only way of achieving a sum of 11 is to put 1 and 2 in here, but you can see that with the given 2s, this won't happen. So that's not an 8, that's a 6. The other 2 digits must sum to 5 without using a 2, so they must be a 1 and a 4. Then you see that there's a 1-3 pair in here, so that's actually a 4. And that's a 1, which resolves the 1-3 pair here. The prime number was 13 after all, and this disambiguates this 1-3 pair. And then this can't be 4 or 5, so only 2 is available. Here, that's not a 3, so it must be from 5, 8, and 9. And there has to be a 6 somewhere in here, not sure where. There must be a 3 somewhere in here. Those are from 2, 7, 8, and 9. So, but perhaps we can think about this 23 clue. So we already have a 3. If I try to make this a 1, the remaining 2 digits would have a sum of 19, which is impossible. So I can remove 1 from this cell and put it here. If I try to put the 4, that's 7, I need another 16. 6 would need a 10, that's not possible. 9 would need a 7, that's not possible. So that's a 5 and that's a 4. And this 4 disambiguates that. And this 5 says that there must be a 4 in here. I need 5, 6, 9 there. So here I'm left with 8. So the remaining 2 digits must have a sum of 15. And considering one of them is 6 or 9, the other must be 6 or 9 as well. And must be the other 6 or 9. I mean, if this is 6, then this has to be 9, and conversely. So this digit can't be, this digit must be different from this one and from this one, so it can't be 6 or 9, it has to be a 5. So that's a 4 and that's a 5. And this digit is the same as this one. This row still needs 1, 2, 4, 1, 3, 4, 5. So here it can only be a 3. Here it can only be a 1. And then this has to be a 4 and this has to be a 5. 8 there, 5 here. And this now can only be an 8 on this row. We need 6, 8, and 9 on this row, and because of this, it has to be an 8. So that's the 9. That's a 6, and let's remember that this digit and this digit had to be different. So that's the 6, that's the 9, that's the 6. 8, 9, and 6 in here. And now the rest should be just standard Sudoku, so let's move on to the real Sudoku part. So here I need 3 and 8, there's an 8 here. Up there, that's not a 4, so 4 goes there, and this is a 6. 6 and 9, so that puts a 5 in here. Here I need a 3 and a 7, there's a 3 on this row. 2, 7, 8, so that's 2. That's not 8. I need a 1 somewhere. It can only be here. It puts the 2 down there. That's a 7, 9 pair. So 9 here, 7 there. This 9 disambiguates all of that. And we're left with the last 2 digits, which are 5 and 9, and that's it. So a very nice idea, and a puzzle with a logic that flows very naturally, I think, and very nice theme. So great creation by Fabien. That's a very nice start. I hope he will find time to create more puzzles, more Sudokus or anything else. And a huge thanks for this very kind present. Thanks for watching this video, and see you soon on SudoKanard.